Hello, cosmic traveler. If you're here, lying comfortably preparing to sleep, it's because you know that the universe holds mysteries that soothe the mind and expand the imagination. Have you ever stopped to think about how many planets exist out there, orbiting distant stars, each with its own secrets? Today, we're going to explore exoplanets, those alien worlds that defy our imagination. And here's a question for you to ponder. If there are trillions of planets in the galaxy, are we really alone? Throughout this gentle journey, I'll use simple examples to unravel these bizarre and fascinating worlds. And at the end, I have an impressive curiosity about an exoplanet so strange that it defies all the laws we know. Take a deep breath, relax, and let's travel together to worlds beyond imagination. Close your eyes for a moment and imagine looking at the night sky. Each star you see may have its own planetary system, entire worlds orbiting those distant points of light. These planets, which exist beyond our solar system, have a special name: exoplanets. They are alien worlds, each unique, each telling its own cosmic story. For most of human history, we only knew about the planets in our own cosmic backyard. Mercury, Venus, Mars, the gas giants. They were the only worlds we knew existed. But there was always that question whispering in our imagination. What if other stars also have planets? What if the universe is full of them? The answer began to reveal itself in 1992, when astronomers discovered the first confirmed exoplanet. But it wasn't orbiting an ordinary bright star. It was orbiting a pulsar, a stellar corpse, a rapidly spinning neutron star emitting regular pulses of radiation. It was a strange and unexpected system. Planets orbiting a dead star, bathed in lethal radiation. It was like discovering life growing in the ruins of something that should be barren. These planets likely formed after the death of the original star, or miraculously survived the supernova that destroyed it. Either way, it was a fittingly strange first discovery for a new era of exploration. But the discovery that truly changed everything came 3 years later, in 1995. Astronomers found the first exoplanet orbiting a star similar to the Sun, a normal, ordinary star called 51 Pegasi. The planet was nicknamed 51 Pegasi b, and it was completely different from anything we expected to find. It was a gas giant larger than Jupiter, but orbiting its star absurdly close, closer than Mercury is to our Sun. It completed an orbit in just 4 days. It was shocking, revolutionary. The models of planetary formation had to be revised. The universe was stranger than we imagined. And that was just the first droplet of what would become a deluge. Currently, thanks to increasingly powerful telescopes and ever more sensitive detection methods, we have already confirmed more than 5,000 exoplanets. 5,000 alien worlds, each orbiting its own star, each with its own unique characteristics. And there are literally thousands more awaiting confirmation. Every year, hundreds of new worlds are added to the list. It's an explosion of discoveries that is rewriting our understanding of just how common planets really are. The answer: extremely common. Virtually every star you see probably has planets. But how do we detect these distant worlds? Most have been discovered using the transit method. Imagine a star shining constantly. Now, imagine a planet passing in front of it from our point of view. For a few hours, the star's light dims slightly, blocked by the planet. It's like a mini eclipse happening thousands of light years away. space telescopes like Kepler and TESS monitor thousands of stars simultaneously, measuring their brightness with incredible precision. When they detect periodic and regular dips in light, they know there's a planet passing in front. It's an elegant method that has revealed most of the exoplanets we know about. The second most commonly used method is called radial velocity. It works like this. When a planet orbits a star, it isn't simply circling while the star remains stationary. In fact, both orbit their common center of mass. It's a subtle gravitational dance where the star wobbles slightly as the planet orbits it. By carefully measuring how the star's light changes, we can detect this tiny wobble. It's like watching someone spinning a bowling ball tied to a string, the person's body swaying slightly with the weight. This method allows us not only to detect planets, but also to estimate their mass. And the planets we've discovered are absolutely bizarre. Some exoplanets are so gigantic and so close to their stars that they're aptly called hot Jupiters. They are hellish worlds, gas giants larger than Jupiter, but orbiting their star closer than Mercury orbits the Sun. These hot Jupiters orbit their stars in just a few days, some completing an orbit in less than 24 Earth hours. Imagine, an entire year passing in less than a day. The temperatures are absurd, thousands of degrees, with supersonic winds eternally sweeping through their atmospheres. These are environments so extreme that they defy the imagination. And there are even stranger worlds. We've already discovered exoplanets orbiting two suns at the same time. Binary systems where two stars dance around each other and planets orbit both. It's exactly like Tatooine in Star Wars, that desert planet with two suns in the sky. Science fiction has become reality. Imagine being on the surface of one of these circumbinary worlds. The sky would display two suns rising and setting in complex patterns, their double shadows dancing in unpredictable ways. It would be a unique celestial spectacle, impossible to experience in our system with only one sun. The diversity of exoplanets is truly impressive. We have already detected exoplanets with a density greater than pure iron. These are incredibly compact worlds, probably made almost entirely of metal, exposed planetary cores whose atmospheres were stripped away by some cataclysmic event in the distant past. And at the other extreme, we find planets so light, so spongy, that they would float on water if they could be placed in a giant ocean. Imagine that, an entire planet with a density less than that of water. These worlds are probably gas giants inflated by the intense heat of their nearby stars, their atmospheres expanded into immense, tenuous spheres. When searching for potential life on other worlds, we focus on what we call the habitable zone. This is the region around a star where temperatures are suitable to allow for the existence of liquid water on the surface. Not too hot where water boils, not too cold where it freezes completely. It's like the story of the three little bears. We don't want it too hot, we don't want it too cold, we want just the right amount. But here's the secret. Not every planet in the habitable zone is actually habitable. The atmosphere makes all the difference. Venus is technically close to the habitable zone, but its dense, toxic atmosphere has created a runaway greenhouse effect that has turned it into a hellish place. And some of the exoplanets we've discovered are so extreme they seem straight out of nightmares. There are worlds that receive such intense radiation from their nearby stars that it literally rains molten glass, and these supersonic winds cause the rain to fall horizontally at thousands of kilometers per hour. It's a hell of sharp glass flying through the air. Other planets are as dark as coal, absorbing almost all the light they receive and reflecting less than 1%. They are worlds blacker than fresh asphalt, invisible ghosts orbiting their stars, detectable only by the gravitational effects they exert. The hottest exoplanet ever found exceeds 4,000 degrees Celsius, hotter than many red dwarf stars. It is so hot that metals would instantly vaporize in its atmosphere, perhaps even atoms beginning to ionize. It's more of an oven than a planet, a cosmic furnace. At the other extreme, the coldest known exoplanet has temperatures close to minus 270 degrees Celsius, just a few degrees above absolute zero. It is a frozen world floating in the icy void of deep space, so far from its star that it barely receives any heat. It is eternal darkness and cold. There are also exoplanets with orbits so immensely long that they complete their orbit so far from the star that a year there lasts thousands of Earth years. Imagine, entire civilizations could emerge and disappear during a single season on these worlds. The star would be just a distant, bright point in the sky, providing little light and almost no heat. And here's the question we all ask: is there life out there? To date, no exoplanet has been confirmed to harbor life. No definitive signs of alien biology have been detected. But many promising candidates continue to be studied. Rocky planets in the habitable zone of stable stars with the potential for atmospheres and oceans. The search continues, each discovery bringing us closer to the answer to one of humanity's deepest questions. Are we alone? And the more we explore, the more we realize how diverse the family of exoplanets truly is. Some of these distant worlds have days that last for weeks because they rotate extremely slowly on their axis. Imagine waking up, seeing the sun rise and knowing it will remain in the sky for days before finally setting. The concept of day and night would be completely different. Other planets do the exact opposite, spinning so fast that they complete an entire day in less than 10 Earth hours. It's a dizzying rotation where the sun would rise and set 2 or 3 times during what would be a single workday here on Earth. Time would simply function differently, and the extreme temperatures we find on some of these worlds are truly impressive. There are exoplanets where surface temperatures reach 3,000 degrees Celsius, enough heat to melt rock instantly to vaporize metals. These are worlds where the very ground would be molten, oceans of lava bubbling under blazing skies. At the other thermal extreme, we have discovered worlds so absurdly cold that molecules barely move. These are temperatures close to absolute zero, where almost all molecular activity ceases. It is a cold that goes beyond any winter we can imagine, a cold that freezes not only water, but even gases that normally remain gaseous. One particularly icy exoplanet, called Ogle 2016 BLG 1195LB, is so extremely cold that it has earned the fitting nickname Deep Ice Planet. It's a frozen world floating in the dark depths of space, so far from its star that it barely receives any heat. If you could somehow set foot on its surface, it would be like being in the icy void of deep space. And remember those worlds that orbit 2 suns simultaneously. Astronomers have found several circumbinary planets, worlds that literally have 2 suns in the sky, like in Star Wars. But nature has gone even further. Some discovered systems have up to 3 stars, creating incredibly complex gravitational systems. Imagine being on the surface of a planet in a triple star system. The sunset would be triple, with 3 suns setting below the horizon at different times, creating multiple shadows that would dance and transform in unpredictable ways. The night sky would never be completely dark as long as at least one sun remained above the horizon. And the atmospheres of these alien worlds can be truly bizarre. Giant gas exoplanets may have literal rain of crystals, formed when vaporized minerals in the warm layers of the atmosphere cool at higher altitudes and condense into microscopic gemstones that fall like shimmering snow through the clouds. Some rocky exoplanets larger than Earth may have global oceans with depths exceeding 100 kilometers, something completely impossible on our planet. These are worlds where water completely dominates, oceans so deep that the pressure at the bottom would be crushing, perhaps even transforming the water into exotic forms of ice that only exist under extreme pressure. And the atmospheric compositions vary in unbelievable ways. There are worlds with atmospheres made of methane, others dominated by toxic ammonia, some enveloped in dense carbon dioxide, and even some with metallic vapor, where metals like sodium and potassium have evaporated and float as glowing metallic clouds. Before we continue exploring these fascinating worlds, tell me, where are you watching from right now? Are you comfortably in bed, imagining these alien landscapes? Or perhaps on a cozy sofa, letting your mind wander to distant worlds? Let us know in the comments where you're discovering the universe with us tonight. And there is a particularly intriguing exoplanet called 55 Cancri A. Analyses of its composition suggest that its interior may be extremely rich in carbon. Under the absurd pressures and temperatures inside, this carbon may have crystallized. In other words, there may literally be layers of diamond inside this planet. A world with a diamond heart floating in space. And some of the strangest exoplanets are the so-called puffed planets, or balloon planets. They are so light, so spongy relative to their size, that they look like gigantic balloons. Enormous in diameter, but with a density less than cork. If we could somehow place one of these in a sufficiently large ocean, it would float like a beach ball. Among the types of exoplanets we find, there are categories that don't exist in our solar system. There are worlds known as super-Earths, rocky planets larger than Earth, but not massive enough to become gas giants. They are like enlarged versions of our world, potentially with stronger gravity, taller mountains, and larger-scale geological features. We also discovered mini-Neptunes, small versions of Neptune with dense atmospheres of hydrogen and helium surrounding rocky or icy cores. They are intermediate worlds between rocky planets and gas giants, filling a category that we simply don't have in our planetary system. But some exoplanets are in truly precarious situations. Some orbit so absurdly close to their stars that they are already being slowly evaporated by the intense radiation. The extreme heat rips atoms from the upper atmosphere, creating a tail of gas that constantly flows into space. This gas tail from these dying planets creates what astronomers call planetary comets, a very rare and spectacular phenomenon. These are planets literally bleeding their atmospheres into space, leaving luminous trails like comets, but on a planetary scale. Eventually, over millions of years, they may lose their atmospheres completely, leaving only bare cores. And there is a particularly lonely and melancholic category of exoplanets. Astronomers have already detected evidence of rogue planets, also called orphan planets. These are exoplanets without any star, floating alone through interstellar darkness, with no sun to orbit, no source of light or heat other than their own residual internal heat. How did these solitary worlds come about? These orphan planets likely formed normally within planetary systems, but were ejected by violent gravitational interactions. Perhaps a close encounter with another planet or a passing star. They were hurled into the interstellar void like cosmic billiard balls, condemned to wander eternally. And here's something that should make you pause. The Milky Way may harbor billions of rogue planets, perhaps even more orphan planets than planets orbiting stars. They are extremely difficult to detect because they have no star to illuminate them, floating invisibly through the darkness. Our galaxy may be full of these ghost worlds that we will never see. Returning to the search for life, some discovered exoplanets are located precisely in the so-called habitable zone of their stars. This Goldilocks zone is where temperatures are suitable to allow liquid water on the surface. And where there is liquid water, there is at least the possibility of life as we know it. Of course, being in the habitable zone doesn't guarantee habitability, but it dramatically increases the chances. These are the worlds we study most closely, looking for signs of oxygen-rich atmospheres, for chemical signatures that could indicate biological processes. They are our best candidates in the search for life beyond Earth. And now, let's explore some of the most extreme and bizarre exoplanets ever discovered. Some of these worlds orbit so absurdly close to their stars that they complete an entire year in less than 10 Earth hours. Imagine being born, aging for decades, and experiencing hundreds of thousands of years during a normal human life. The concept of year would completely lose its meaning. These ultra-hot worlds are aptly named hot Jupiters. They are massive gas giants, comparable to or larger than Jupiter, but literally roasted by the extreme heat of orbiting their stars closer than Mercury orbits our Sun. Their atmospheres are fiery furnaces, where metals evaporate and clouds of vaporized rock float across infernal skies. But here's the mystery. The hot Jupiters probably didn't form where they are now. The most widely accepted theory is that they were born far away, in the cold outer regions of their systems, where gas giants typically form. But over millions of years, they were gravitationally pulled closer to the star through a process called planetary migration. And this migration can be catastrophic for the system. Imagine a gas giant the size of Jupiter plunging toward the interior of the system. It could destroy smaller planets in its path, eject them into interstellar space, or simply swallow them. The entire architecture of the planetary system is violently rearranged by this gravitational journey. The atmospheres of these extreme worlds are truly alien. Some exoplanets have atmospheres literally filled with vaporized iron. The heat is so intense that the iron, which we think of as a solid metal, is completely evaporated, floating as a gas. And when this iron vapor rises to cooler altitudes, it condenses and falls as metallic rain, liquid droplets of molten iron plummeting through the clouds. And in slightly cooler, yet still extremely hot worlds, there are fascinating theoretical predictions of sapphire and ruby rain. How is this possible? Thanks to the presence of aluminum and titanium in the atmosphere, which, under certain temperature and pressure conditions, can crystallize into aluminum oxides, exactly the same minerals that form these precious stones on Earth. Showers of jewels falling from the alien sky. And going back to that intriguing world mentioned before, the exoplanet 55 Cancri E. Analyses strongly suggest that it likely has an entire crust of crystallized carbon. Under the absurd pressure and temperature, this carbon would crystallize into diamond. It is literally a diamond planet, a world with diamond mountains, subsurface oceans of liquid diamond, a cosmic treasure on a planetary scale. And the winds on some of these worlds are truly terrifying. Some exoplanets have supersonic winds that reach 8,000 kilometers per hour, faster than the speed of sound on Earth by a factor of 6. These winds can circle the entire planet in a few hours, creating perpetual storms that never cease, transferring heat from the eternally illuminated day side to the eternally dark night side. And remember those systems where planets orbit 2 stars simultaneously. These circumbinary systems are fascinating, not only because they have 2 suns, but because of the completely bizarre lighting cycles they create. Imagine, the 2 stars orbit each other, and the planet orbits both. Depending on their relative positions, you could have double eclipses, multiple shadows constantly changing, patterns of light and darkness impossible to predict without computers. Some of these circumbinary planets are fortunate enough to reside in double habitable zones, where 2 combined stars provide just the right amount of heat to allow liquid water. It would be a delicate, yet potentially habitable gravitational ballet. A world illuminated by 2 suns of different colors, creating a unique blended light. But not all binary systems are kind to their planets. Other worlds become trapped between 2 stars that gravitationally compete for the planet, pulling it in different directions. This can cause unstable and chaotic orbits, where the planet wobbles wildly, its orbit changing over centuries or millennia, temperatures fluctuating wildly as the distance from the stars changes. And there are worlds with orbits so immense that there are worlds where the year is literally longer than the lifespan of a human being. Thousands of Earth years to complete a single orbit around a distant star. Entire civilizations could arise, flourish, and disappear during a single season on these worlds. The star would be just a bright point in the sky, changing position almost imperceptibly over generations. A particularly extreme exoplanet, called HD 1006-906b, is so absurdly far from its star that it takes 80,000 Earth years to complete a single orbit. 80,000 years. The entire history of human civilization, from cave paintings to space rockets, would comfortably fit into a single orbit of this distant world. And exoplanets exist across the entire range of cosmic ages. Some are so young, only a few million years old, that they are still glowing from the residual heat of their formation. They are like unfinished stars, worlds still contracting under their own gravity, radiating infrared heat as they slowly cool and stabilize. Other exoplanets are extremely old, true cosmic elders. Some formed when the universe was only 1 billion years old, about 13 billion years ago. These ancient worlds formed from primordial material containing far fewer heavy elements than younger systems. They are planetary fossils from the early universe, and the orbits of these worlds can be truly strange. Some have orbits that are extremely inclined relative to the equator of their stars. Instead of orbiting in the same equatorial plane as the planets in our solar system do, they pass over and under the star's poles, plunging dramatically through the system at impossible angles. And when the orbit is too inclined, something even more bizarre can happen. The planet can literally jump from one hemisphere to the other over centuries or millennia, its orbit slowly precessing, like a spinning top that wobbles as it turns. It's a chaotic orbital dance that defies our simple models of planetary systems. And there are even exoplanets orbiting dead stars. Some discoveries show planets circling white dwarfs, those dense stellar remnants the size of Earth, but with a mass comparable to the Sun. They are stellar corpses, what remains after stars like our Sun exhaust their fuel and eject their outer layers. These worlds likely miraculously survived the violent death of their stars. When a star becomes a red giant before collapsing into a white dwarf, it can swallow inner planets. But some, perhaps because they are at the right distance, or because they are pushed out by gravitational interactions, survive. And they bear the scars of the stellar explosion, perhaps covered in ejected material, solitary witnesses to the death of their sun. And as we approach the end of this relaxing journey, let's revisit and delve deeper into some of the most fascinating extremes we've discovered. Some exoplanets orbit so absurdly close to their stars that a full year lasts only 8 Earth hours. 8 hours. Less than a workday here would be an entire year there. At the other end of the scale, there are worlds so distant from their stars that it takes thousands of Earth years to complete a single orbit. These are planets where countless generations would be born and die, seeing the star in the exact same position in the sky, changing so slowly that it would be imperceptible during an entire human lifetime. And when we started cataloging these worlds, we discovered something completely unexpected. In many systems, there are planets larger than Jupiter orbiting closer to their stars than Mercury orbits our Sun. This completely contradicts models of planetary formation based on our solar system, where gas giants reside in the cold outer regions. These extreme planets have been aptly named hot Jupiters. They are massive gas giants, but scorched by their proximity to their stars. On a typical hot Jupiter, atmospheric temperatures can easily exceed 2,000 degrees Celsius. That's enough heat to vaporize many metals, to make rocks glow red, to create environments that defy imagination. And these worlds are not static. Atmospheric winds on these planets can reach speeds of 8,000 kilometers per hour, faster than any hurricane, tornado, or storm ever recorded on Earth. These are winds that could literally tear apart any structure, transferring heat around the planet at supersonic speeds. And some of these winds carry something truly bizarre: vaporized metallic particles. This creates literal rain of liquid titanium or iron in certain regions of the atmosphere, droplets of molten metal plummeting through alien skies. It's a hydrological cycle, but instead of water, it's metal. Clouds of metallic vapor condensing into metallic rain that falls and then evaporates again. Many of these hot Jupiters develop another extreme phenomenon: synchronous rotation. They are exoplanets with eternal days, where one side is always facing the star in perpetual light and heat, while the other side remains in permanent darkness. It's like our moon, which always shows the same face to Earth, but on a planetary scale and with extreme consequences. On the sunlit side of these worlds, temperatures are so extreme that they melt rocks. The surface would be a global ocean of bubbling lava, liquid rocks flowing like water, an eternal inferno of heat and light. The concept of solid ground simply wouldn't exist there. But on the dark side, eternally turned away from the star, temperatures plummet. It is eternal darkness and cold. There, vaporized rocks flowing from the day side through powerful winds can resolidify as they cool, forming bizarre mountains and jagged surfaces sculpted by completely alien processes. It is a world divided between fire and ice, and the diversity of compositions continues to surprise us. We have already discovered exoplanets formed almost entirely of water, but not water as we know it. It is supercompressed water in exotic states that do not exist naturally on Earth. Under immense pressure, water can form dense crystals called hot ices, which remain solid even at temperatures of hundreds of degrees. Some of these aquatic worlds may have global oceans so deep, hundreds or even thousands of kilometers deep, that the pressure at the bottom would instantly crush any terrestrial submarine. There, water exists in forms we barely understand, perhaps even forming layers of exotic ice denser than normal rocks. And the extremes of density are truly impressive. The densest exoplanet ever measured has a density comparable to pure solid lead. This indicates an extremely metallic composition, perhaps an exposed planetary core whose outer layers were stripped away by some ancient catastrophic collision. It's basically a planet-sized ball of metal floating in space. At the other extreme, the lightest exoplanet discovered appears to be absurdly fluffy, with a density less than styrofoam. It is a gas giant, so inflated by the heat of its nearby star that its outer layers are thin, almost like a vacuum. It is enormous in size but nearly empty, like a gigantic cosmic balloon. And going back to those systems with multiple stars, exoplanets in binary systems can actually experience the romanticized double sunset in Star Wars. Two stars setting on the horizon at slightly different times, creating double shadows that dance and merge as the suns set. And in even more complex systems with three stars, an observer on the surface of a planet could see 3 or even 4 shadows at the same time, depending on the relative positions of the stars. Each shadow would move differently, creating constantly changing patterns of light and darkness that would be impossible to predict without complex computation. There are worlds so young, only a few million years since their formation, that they are still literally glowing due to the residual heat from their formation. They are infant planets, still contracting under their own gravity, radiating infrared heat as they slowly cool and stabilize into their final forms. And at the other temporal extreme, there are exoplanets so incredibly old that they may have formed even before the Milky Way and Andromeda collided for the first time billions of years ago. These are ancient worlds that have witnessed entire eras of the universe pass, silent witnesses to cosmic events that occurred long before our sun even existed. And here's a fascinating possibility that's capturing the imagination of astrobiologists. Giant exoplanets, especially those in habitable zones, may heat their own moons through gravitational tidal forces. These moons, constantly flexed by the massive planet's gravity, generate internal heat through friction. This would make these exotic moons better candidates for life than the giant gas planets themselves. Imagine a rocky moon with liquid oceans kept warm not primarily by the distant star, but by the giant planet it orbits. It's like Europa or Enceladus in our solar system, but potentially even more habitable. And some theoretical models suggest something even more intriguing. Civilizations could potentially exist on these moons orbiting giant planets, where the star would not be the only source of energy. They would have access to tidal heat, the magnetic protection of the giant planet, and would still receive light from the distant star. These would be unique hybrid ecosystems in the cosmos. And so we come to the end of this relaxing journey through the alien worlds of the universe. Let's explore the last fascinating extremes we've discovered among exoplanets. Some of these worlds orbit so absurdly close to their suns that they complete a full revolution in less than 10 Earth hours. These are the so-called ultra-short hot Jupiters, veritable cosmic clocks spinning at dizzying speeds, where the concept of year completely loses the meaning we know. And the extreme proximity creates bizarre phenomena. On some of these worlds, stellar gravity is so intense that it literally pulls on the planet's upper atmosphere, stripping away gas and creating tails that flow into space like giant comets. These are planets bleeding their atmospheres, leaving gaseous trails as they orbit their stars. In worlds close to white dwarf stars, those dense, hot, stellar corpses, intense ultraviolet radiation can turn entire oceans into vapor. The water is broken down into hydrogen and oxygen, which then escape into space. We have already detected exoplanets that have lost more than half their mass through this stellar evaporation process over billions of years. And eventually, some of these tortured planets become truly dead, leaving only their metallic core exposed. They are like naked planetary hearts floating through space. All that remains after outer layers of rock and atmosphere have been completely stripped away. They are planetary fossils, evidence of violent processes. At the opposite extreme, there are worlds so distant from their stars that temperatures drop to minus 250 degrees Celsius, almost absolute zero. These are icy worlds, where even gases like nitrogen and methane freeze into solids, where any heat is only the faint residual glow of the planetary core. But here's something fascinating. Studies suggest that even completely isolated icy planets, so-called starless rogue planets, may have liquid internal oceans. How? Heated by natural radioactivity in the core. The decay of radioactive elements could generate enough heat to keep liquid water under thick layers of ice. What if these subsurface oceans exist on rogue planets? They could serve as a home for simple life forms. Organisms that would never see starlight, that would exist in perpetual darkness, nourished by chemical processes around hydrothermal vents. Life without sun, thriving in the icy heart of lonely worlds. Some exoplanets orbit stars so faint red dwarfs, that during the day, the sky would appear almost as dark as night on Earth. The star would be a faint red disk, providing little light, creating environments of perpetual twilight where photosynthesis as we know it would be impossible. Others orbit stars so dim and reddish that the sky would have a permanent blood orange hue. Imagine living under eternally red skies, where blue never exists, where all light is tinged with crimson. It would be a profoundly alien environment, but potentially habitable with the right adaptations. And the orbital timescales vary absurdly. We've already found exoplanets where a single year lasts more than 300,000 Earth days. Almost 1,000 Earth years to complete an orbit. Countless generations would be born and die seeing the constellations in the exact same position. Meanwhile, there are planets so close to their stars that the star literally occupies half of the visible sky. Imagine looking up and seeing not a small solar disk, but a fiery wall of plasma covering half your vision. These would be eternal sunrises where the sun never fully sets, dominating the sky like a furious god. On supermassive worlds, super-Earths with several times the mass of Earth, Surface gravity can be so strong that a human being would barely be able to lift a finger. Their own weight would be crushing. Muscles fighting against a gravity 3 or 4 times stronger than here. It would be like wearing a lead diving suit permanently. And the internal structure of these massive planets could be completely different from Earth's. Instead of oceans of water, they could have global oceans of liquid ammonia, seas of methane, even layers of liquid metallic hydrogen under absurd pressures. They would be worlds of alien chemistry, hydrological cycles based on substances that on Earth are only gases. Some of these giant exoplanets can generate magnetic fields 1,000 times stronger than Earth's. They are planetary dynamos operating on a titanic scale. And if these intense magnetic fields interact with charged stellar winds, they can create auroras so intense, so bright, that they would illuminate the entire planet in perpetual displays of light. There are planets with extraordinary celestial neighborhoods. Some orbit amidst dense star clusters, seeing not 1 or 2 suns, but hundreds of stars at once. The night sky ablaze with light from countless nearby suns. It would be an unimaginable firmament, without true darkness, only constant light from all directions. And others are at the opposite extreme, so isolated in deep space, so far from any star, that they live in near total darkness. They are solitary travelers of the galaxy, wandering planets floating through the interstellar void, illuminated only by the faint light of distant stars, experiencing a cosmic loneliness that we can scarcely comprehend. And here's the fascinating tidbit I promised at the beginning. Among all these extreme and bizarre worlds, there's an exoplanet called Kepler 402b that defies everything we know. It orbits a star remarkably similar to our Sun, is in the perfect habitable zone, has a size and mass comparable to Earth, and its year lasts 385 days. It's so similar to Earth that scientists have nicknamed it Earth 2.0. But here's the mystery. It's 1/400 light-years away, so the light we see from it today left there in 625 AD. If there is intelligent life there, they would still be in the Middle Ages when they last looked in our direction. It's a profound reminder that the universe operates on timescales that make instantaneous communication impossible. And amidst this extreme diversity of worlds we've discovered, from scorching hot Jupiters to frozen rogue planets, from massive super-Earths to diamond planets, each new exoplanet discovered statistically increases the probability that one of them is truly like Earth. Blue with oceans, green with life, shrouded in white clouds, full of mysteries and perhaps, just perhaps, gazing back at us through the void. So, as you relax now, ready to sleep, think about this. Out there, orbiting stars so distant that their light takes centuries to reach us, there are trillions of worlds. Some are fiery hells, others are icy deserts. Some are covered in deep oceans, others have skies of colors we've never seen. And among all these alien worlds, there may be 1 or 10 or millions, where someone else is also looking at the stars, contemplating the same questions, dreaming of distant worlds. If you enjoyed this journey through the alien worlds of the cosmos, leave a like and subscribe to the channel for more relaxing explorations of the universe. Your support helps create more content like this that helps you fall asleep while discovering the mysteries of space. Good evening, explorer of distant worlds. May your dreams take you to those bizarre and fascinating exoplanets, to alien oceans beneath crimson skies, to diamond planets shimmering in the void. The universe is stranger and more wonderful than we can imagine, and you have just journeyed through 100 of its most fascinating mysteries. Sleep well, knowing that the cosmos is full of worlds waiting to be discovered, each with its own stories, its own secrets. The journey of space exploration is only just beginning.